Okay, we're going to find the average rate of change of these functions on these intervals. So let's look at the first one. We have f of x is equal to 12x plus 8. In fact, you know the answer already. It's just 12 because this right here, it's the linear function, right? 12x to the first power plus 8. But if you use the formula, we'll still end up with the same answer, and let me demonstrate the formula because that's the purpose of this video. So have a look. I'll just put down the average rate of change as ARC. Remember, if we are going from 5 to 8 and these are the x values, that means we have to do the following. F of 8, right? F of 8. And then minus f of 5. And then we divide it by 8 minus 5. So this right here, right? And this is actually just a slope formula if you have seen the slope formula before. Okay, I will recommend you guys to work this out and work this out separately, and then we'll see what happens at the end. So have a look here. Let me just put this down right here for you guys. Let's look at f of 8. Well, for this, all I have to do is put the 8 in here, so we have 12 times 8, and then we add the 8 after that. And now for this, you can just work it out real quick. This right here is 96 plus 8, which is going to give us 104. Secondly, we have f of 5, so let's put that down. And this is 12 times 5, and then plus 8. This is 60, and then we add 8 to that, which is going to be 68. So just like this. Okay, then we see this right here, of course, we know it already, which is 104. And then we will subtract f of 5, which is 68. And then divided by 8 minus 5. Okay, let's see. What's 104 minus 68? I think that should be 36. So we have 36 on the top. And then over the bottom is just going to give us 3, right? Because that's 8 minus 5. So finally, we have 36 over 3. And in the end, of course, reduce that. We end up with 12. 36 divided by 3 is 12. And I told you this right here is that. In fact, whenever you have a linear function, it does not matter where you go from to where you end. The average rate of change is always the coefficient of the x. However, it's a different scenario for this one though, because we have x to the second power minus 4x. So we really do have to know the formula. Anyway, here we go. This right here is about g, so that's a name. Anyway, I will still put down ARC for the average rate of change. We are going from 1 to 5. So we put down g of 5 minus g of 1 divided by 5 minus 1. So this right here will be the setup. Now, let's see what's g of 5. For this, all we have to do is put a 5 in here and also in here. So we get parentheses 5 and then square that and then minus 4 times 5 like this. Well, this is 25 and this is 20. So all in all, we end up with 5. Similarly, we'll do g of 1. G of 1 is right here. And that means I will put down 1, square that, and then minus 4 times 1. 1 for the x value here and here. And then we see this right here is 1, minus this right here is 4, and 1 minus 4, we end up with negative 3 like this. So this right here is going to give us the following. G of 5 is 5, and then minus g of 1, which is negative 3. So let me bring down this minus here. G of 1 is negative 3, so it's a negative 3. And technically, I should put that down in the parentheses. And then divided by 5 minus 1. Okay, now on the top, we have 5 minus negative 3. So this right here is the same as saying 5 minus negative times negative becomes a plus. So we have to do 5 plus 3, and that will give us 8. Over 5 minus 1, which is a 4. Divide 8 by 4, we end up with 2. So the final answer for this is 2, right? So this is how we find the average rate of change of a function from x value to another x value. That's it.